What does change of base formula look like?
1.6532.
That's the answer to the first problem. What does change of base formula look like? So if I have log of some base with an argument, what would it look like for me to change that base? Close. Argument over base. So we have log of our new base, original argument, over log of whatever that new base is that we chose, with the old base as the argument there. Most of the time, if we're going to be using our calculator to evaluate these, what base do we want to choose? What do we have the ability to use on our calculators? Log. If you just see LOG, that's base what? Base 10. So log base 10, or common log of the argument, over log base 10, common log of the base. Remember, when you see just LOG, that is log base 10. We learned another one on Wednesday. What did we talk about on Wednesday? It was log base E. And how do we abbreviate that one? LN. If you see LN, that's the same as log base E. So if I'm going to change the base, I could use log base E, because that's also one that's on my calculator. I can use either one of those because both ln and common log are on my calculator. All right, number one on the bell work. Do I need to use change of base on this one? Why not? Yes. This right here is already base 10. So we just type this one into the calculator. And you get what? Precious, this is what you gave me at first. 1.6532. Why go out to 4 decimal places? Yes, nearest 10,000th is telling me 4 decimal places. Just as a reminder, anytime we see log, what we're trying to find over here is the exponent. So this is saying 10 to what power gives me 45? 10 to 1.65. If I do that in my calculator, I'd get something really close to 45. What question is number 2 asking me? If I was to think about it in the same way that I wrote 10 to some power equals 45, what is number 2 asking me to find? What's the base on this log in number 2? 4. So 4 to some power equals 256. Is that one that we could figure out without a calculator? Maybe. Not square rooting. If I don't know how to do it on my calculator, I could use change of base here. What would it look like for me to use change of base? Log. Look at our model over here. What does the A stand for? What does the A stand for? Argument. What is the argument for this log? 256 is the argument. So log of 256 over log of what? Log of 4, the original base. So now I can put it into my calculator as a fraction. Yes, you do need calculators. That's why it says grab a calculator. What would this be? 4. This one came out to be exact. Not approximate at all. It came out as exactly 4. Try this for me on your calculators. I want you to put in not the common log, but use the ln button. ln of 256 divided by ln of 4. And tell me what you get. 4. We can change the base to any base we want. We can use the common log base, 10, or we can use the natural log base e. It just has to be the same in the numerator and the denominator. If you go with common log on top, it has to be common log on bottom. If you go with natural log on top, it has to be natural log on bottom. Number 3. This is asking me to find what? What does log base 2 of 15 mean? 2 to what power gives me 15? Well, what's 2 to the second power? 4. What's 2 to the third power? 8. What's 2 to the fourth power? 16. I wanted 15. It's going to be 3 point something. It's going to be in between 3 and 4, but very close to 4. What would this look like if I wanted to use change of base to calculate it precisely? Log of 15 over log of 2. Or if I wanted to use natural log instead, this would be natural log of 15 over natural log of 2. Either one of these is going to give me the same exact answer. It's about how much? 3.9068, or you could round it to 3.9069. Why did I use the squiggly there instead of an equal sign? It's not exact, it's not precise. We had to round it. If you use an equal sign instead of a squiggly, will I take off points? No. I'm going to use the squiggly, though, whenever we're rounding. What question is the last one asking me? What does this mean? 6 to the what power equals 2? Well, what is 6 to the first power? 6 to the first power? Would be 6. So what do I already know about that exponent? If 6 to the first power is 6, what's 6 to the 0 power? 1. Yeah, it's going to be somewhere in between 0 and 1. What does this look like when I use change of base? Yep, common log of 2 over common log of 6. Or if I wanted to use the ln button instead of the common log button, how else could I write this to have the exact same meaning? ln 2 over ln 6. And what do we get? 0.3868 or 0.3869, depending on how you round that one. You have to know how to use change of base formula. That is one that I will not give you on the test. So you have to know that one. There's not really much of a formula to it. It's just log of argument over log of base. We were working on your 8-4 notes on Wednesday. We got about halfway through them. These are the ones with the cartoon up in the corner. I don't know. I have to see the front of it. Yep. It's got the cartoon on it. We're going to be down at the bottom of the back side of the first piece of paper. All right. We've worked on some solving already. We're going to continue practicing with solving. We practiced solving in 8-2. We're going to do some more solving here. First step, if I have an exponential equation, first of all, how do I know that this example is an exponential equation and not a log equation? It doesn't say log. And what else do you see? Yeah, it has an exponent right here, right? So it does not say log, and I have something with an exponent on it. Equation. Does not say log. And a base has an exponent. What is the base? What is the thing with an exponent on it? What in this equation has an exponent on it? The e. The -2 doesn't have an exponent on it, but the e has an exponent on it. You're right, that -2 is connected to it, but specifically I want to look for what is the one piece that has those little numbers or letters up next to it. When we are trying to solve this, the very first thing I'm going to do is isolate the base with its exponent. Isolate the base with its exponent. So you told me that was e, because it has the exponent of x plus 3 on it. So we're going to isolate this. What are the pieces, what are the numbers that are not inside that little blue box? -2 and plus 8. What would I have to undo first if I'm going to try to isolate this? Subtract 8 from both sides. That's where I would start. Because tell me about that -2. What is connecting that -2 to the e? Multiplication. We don't ever undo multiplication first. We always undo addition and subtraction first. All right, so I would have -2 e to the power of x plus 3 equals what? What is -14 minus 8? -22. Have I isolated the base with the exponent on it? No. Here's the base with the exponent on it. I still need to isolate this. It's not alone. I need to get rid of this -2 out in front. You told me what operation was connecting the -2 to the e? Multiplication. How do I undo that? With division. So I'm going to divide both sides by -2. That'll cancel my -2 out. I have e to the power of x plus 3 equals, what's -22 divided by -2? Close. 11. Negative divided by a negative gives me a positive there. Do I have the base isolated? Do I have the base with its exponent isolated now? Yes. Base with exponent isolated. All right, so I'm done with the first step. We isolated our base with an exponent on it. Where is x in the equation right now? With the plus 3, it's in the exponent. How do I get exponents alone? How do I get exponents alone on one side? Put it in logarithmic form. So we are going to rewrite this in logarithmic form. If I'm going to rewrite this in log form, what does it have to start with? Log. L-O-G. What would come after the G? The base. What is my base here? E. Here's my base. So it's log base E, little e. What would come after the little e?
X plus 3 or 11.
Which one is it? 11. Why? Because it's the argument. Remember, the whole point of logs is to get what alone? The whole purpose of logs is to get the exponent by itself. Here's my exponent. So that goes over here. We learned on Wednesday a different way of writing this. Log base E is the same as ln. ln of 11 equals x plus 3. I'm going to have to bring that over here. ln of 11 equals x plus 3. What's been the goal of this problem the whole time? Why are we going through all this? What are we trying to do? Solve for x. So the last thing I do here is solve for x. What do I need to do to get the x all by itself now? minus 3 on both sides. That is not going to touch this 11. Remember, the calculator is going to make you put this inside parentheses. So I'm going to have ln of 11 minus 3 equals x. This is my exact solution. When it's written like this, I have not had to do any rounding at all. How would I find the approximate solution?
Put in the calculator?
Yep. Put this in the calculator to find the approximate solution. So let's do that. I'm going to push the ln button. It opens up parentheses. I type in 11, close my parentheses, and then minus 3, and I hit enter. What do you get on the calculator when you put in ln parentheses 11, close parentheses, minus 3?
Negative 0.6021.
Negative 0.6021. Yes. This is our approximate solution. All right. Flip it over to the top of the next page. That's where the check is. It's on the bottom of my screen, but it's on the top of your next page.
Yeah, two checks.
You should only have one check here. It says check, and then it's got example 5 and example 6. Up at the very top, it should say check. And then it's got this problem right here. What is the first step to solving that? I wrote the 3 steps down up at the top. Isolate the base. How do I know if it's a base? How do I know if it's a base? What did I write next to it?
Has exponent.
Has an exponent on it. What thing here has an exponent on it?
E.
E. So this right here, I'm going to isolate. What would I have to do to isolate the e with its exponent? Divide both sides by 6. All right, so I'm going to divide both sides by 6. When you divide 26 by 6, does it come out very nice? No, then we're going to leave it as a fraction. We don't want to round when we're in the middle of our problem. Do I have the e isolated now? Is the e with its exponent isolated? Yes. So now I'm ready to move on to step 2. What was step 2? Rewrite in log form. If I'm going to write this in log form, what does it have to start with? Log. What would come after the G? E, my base. So log base E. What would come after the log and the base E? 26 over 6. This whole thing right here is the argument. And what would that be equal to? 0.25x. Almost. What else does it need? I'm missing something. Plus 3. Right here. That's all part of the exponent there. Log base e is the same as what? ln. This is ln of 26 divided by 6 equals 0.25x plus 3. Did we already isolate the base, the thing with the exponent on it? Yes. Did I get it rewritten in log form? What's next? Can't put it in the calculator yet. Solve for x. I want to get x all alone. I want to get this guy alone. What do I need to do in order to get the x all alone?
You add 3 and we subtract 3 on both sides.
Subtract 3 from both sides. That will not combine with the fraction. I'm going to have natural log of 26 over 6 minus 3 equals 0.25x. How do I get rid of that 0.25? Divide it. So I'm going to divide both sides by 0.25. Everything over here gets divided by 0.25. Everything over here gets divided by 0.25. That makes this cancel.
In the calculator, you put ln parentheses 26 over 6 parentheses negative minus 1 over 0.25.
I'd start off by pushing the fraction key on my button, or on my calculator. So fraction key first, and then ln, and then I'd hit the fraction key again so I can do 26 over 6. Close the parentheses. So again, here's how I'd type it into my calculator. Fraction button first. ln, it opens parentheses, and I'm going to push the fraction button again. 26 on top, 6 on bottom. Close those parentheses. And then what would come after that?
You get answer
Nope. What do I put in the calculator after this?
over 2 point. Yeah,
We're missing something else in the top.
Minus 3.
Minus 3 over 0.25. Make sure you do minus 3 and not negative 3. That is a different meaning. This is my exact solution. When I put it into my calculator, I get my approximate solution. What is the approximate solution?
approximate is negative 6.1346. Or 1347.
Yep. That would be the approximate solution. So if they asked for an exact answer, I would leave my answer like this. If they asked for an approximate answer, or if it said round to the closest, I would leave my answer like this. So over here where they had the squigglies, negative 6.1347. Because they had the squigglies, they had the approximate there. Do you guys have any questions for me about this? Isolate the base, rewrite it in log form, solve for x. Look at example number 4. What does it say?
Solve
5.
Yes, did I say 4?
Yes.
Sorry.
Here.
We're going to solve a natural logarithmic equation. The last one was exponential. This one is logarithmic. How do I know it's logarithmic? Yep. It says either log or ln, which means log base e. My steps for this are almost exactly the same as when I'm solving an exponential. We're going to isolate the log with its argument. You are never allowed to separate a log from its argument. The only thing you can do is rewrite it in a different form. But you cannot separate the log from its argument. What is the log with its argument here? ln, that's the log. What's the argument part? Where do you go looking for an argument when it's in log form? 5x. This right here is what we need to isolate. Whatever comes right after the log or the ln, that will be its argument. Sometimes it'll be in parentheses, sometimes it won't be. What do I need to do to get the ln of 5x all alone? Or what do I have to get rid of? The 1/6. If you see a fraction, what operation is happening? What'd you say? Division. How do we undo division? Multiplication. What's on the bottom of the fraction? Because that's what we need to multiply by. What's on the bottom? What is the number that's the denominator? 6. We're going to multiply both sides by the denominator. That's going to make the denominator cancel over here. So I would have 1 ln 5x equals, what do I get when I multiply the other side by 6? 12. Is my log with its argument isolated? Yes. Log with its argument is alone. Where is x? With the argument. How do I get an argument alone on one side? Write it as an exponential form. So we're going to rewrite in exponential form. What is the base here? Because I need the base if I'm going to write it in exponential form. When you see ln, e. When is it base 10? When you see log, log. When you see ln, it's base e. So I have e. Which piece is the exponent? 12. When it's in log form, this is my exponent. So this is e to the power of 12 equals what? 5x. Here's the argument. What do I need to do to that to get the x all alone? Yes. We're going to divide. Divide by what? Divide both sides by 5. this right here, e to the power of 12 divided by 5 equals x, is my exact solution. How would I find my approximate solution? If I put it in log form, I'm going to be right back at the beginning. How do I find my approximate solution? What did we do last time when we wanted to find the approximate solution? Put it in the calculator. We're going to put everything on this side in the calculator. To find the approximate solution. How do I get the E button on my calculator? Second ln. To get E, push second and ln. So on my calculator, I need a fraction, second ln so that I see E, put in my exponent of 12, divide it by 5. So 5 goes on the bottom of my fraction. And then I hit enter. What do you get when you put that into your calculator? So start with your fraction button, then second and ln so you can get the E. Put in the exponent of 12. In the denominator, put a 5, and then hit enter. You got one? Let me see. That's exactly right. Hezzy, can you read those numbers for me so I can get it written down?
3, 2, 5, 5, 0.
Give me 4 numbers after the dot.
9, 5, 8, 2.
Or if you round it a little bit differently, 3, 2, 5, 5, 0, 0.9583. This would be the approximate solution. All right, how many more problems do we have to go? How many more problems? We got one more problem. We have example number 6 down at the bottom of the page. Oh no, on this we're done. We have one more example and then we're done with 8-4. Can I get somebody to read this for me?
You deposit $8,000 into an account that pays 3.75 interest compounded continuously. How long will it take for the balance to double? Use A-P-E-R.
Do you guys remember A equals P-E-R-T?
Yes, no.
When did we use that? Last month, last module, right?
7.
Module 7. They're telling me right there what formula I need to use. What would we put in for P? 8,000. So here's P. What would we put in for R? The percent. What do I have to do to it when it's got a percent sign on it like that? Divide it by 100. Only when it has a percent sign on it. So 3.75.
Would that be 0.0375?
Yep, 0.0375. That's what we're going to use for R. What do we use for T? Time. What's the time? Look at the question. What does the question ask? If you ask a how long question, what do you want to know?
You want to know the time.
You want to know the time. So we're going to try to find T. I don't have anything to put in for T because I don't know it. That's what I'm trying to figure out.
Well, said, well, don't we gotta find the balance then, the double the balance?
There we go. It says, how long will it take for the balance to double? What was the starting balance, the original amount? 8,000. So here, this is P, so 8,000.
Would it take 16,000?
Why? Because you have to double it. What does double mean to do? Times it by 2. So I'm going to take 8,000 times 2, and you get what? 16,000. This goes in for A. This is a final amount. All right. So let's substitute in. A equals P E to the power of RT. What do I put in for A? 16,000. Equals, what do I put in for P? 8,000. What do I put in for E? E. Why? It's continuously, and E is a number. We don't put anything in for E. It's not a variable. What else do I need? The rate and the time. Where do those go? In the exponent. So 0.0375. There's my rate. What do I put in for T? T. I don't know that one. What kind of equation am I looking at here? Is this a logarithmic equation or an exponential equation? Exponential. Because you don't see what? Don't see log or ln. What was our first step when we wanted to solve an exponential equation? This is what we did in example 4. Yes, isolate the base with what? Yep, with its exponent. So this right here is going to be isolated, which means I need to get rid of what? What's not inside that blue box? 8,000. What's connecting the 8,000 and the E together? What operation? Multiplication is connecting these, so how do I undo it? Divide. Divide both sides by 8,000. So it's going to cancel out here. What's 16,000 divided by 8,000? Divided by. What did you say? I couldn't hear you. Not 2,000.
8,000.
No.
Man, can't use a calculator.
2. All right. Do I have the base with its exponent isolated? Yes. Base with exponent alone. So what's our next step? Once I get the base with its exponent all alone, where do I go from here? Write it in log form. So if I'm going to rewrite this in log form, what does it have to start with? Log, L-O-G. What would come after the G? E, our base. So log base E. What would come after the E? What comes after log and the base? What do we call the piece that comes next? The argument. Which piece of this is my argument? The exponent is not the argument. Those are two separate things. Yes. This is my argument. So the 2 comes next. Equals what? 0.0375 t. Here's my exponent. Yes, we're going to write it as ln instead of log base e. This is ln of 2 equals 0.0375 t. How do I get t all alone?
Subtract.
How do I know whether I'm dividing or subtracting? What's connecting the number I want to get rid of to the variable? Multiplication. How do I undo multiplication? With division. So we're going to divide by 0.0375 on both sides. That'll cancel out. So I need to grab my calculator. What's the first button I push on my calculator? Fraction. What would come after the fraction button? Put log, L-O-G, ln, 2, close my parentheses, down button, 0.0375, and then what do I do? What do I do? I got it in my calculator. Press enter. And what do you see? How much? 18 point, give me 4 places. 4, 8, 3, 9. This is a story problem, so I should have units on this. What did we just solve for? What does t mean? Time. What units of time should we put on this? How long do people normally leave stuff in the bank for? Like a minute, a day? Usually it's going to be years. If you're making a long-term investment to go from $8,000 to $16,000, that's going to take years to happen. So in about 18 and a half years, the balance will double. Why is it 18 and a half years? Why would I say it's about 18 and a half years?
Focus on an exact answer.
I've got an approximate answer. I got 18.4839 That's really close to what? What would 18 and a half be? 18.5. We're really close to 18.5. So in just a little bit less than 18 and a half years. All right. Very nice work. Please put the table down. All right. Couple things briefly to talk about next week. When is your test?
Friday.
Next Friday, so 1 week from today. 8-4 homework, which we just finished up your 8-4 notes. That's due on Monday. That's in McGraw-Hill. There's no paper homework for 8-3 or 8-4. On Monday, we have to do 8-5. 8-5 is like this last example that we did. It's just story problems. We're going to do 2 or 3 story problems using the skills that we've learned. And I'm not going to give you a homework over 8-5. I will give you the test review, though.
When is that going to be?
When are you getting the review? What day? Monday. You'll get the review on Monday instead of getting 8-5 homework. Tuesday is weird. Why?
Because we're not at school, we're online.
You're not in school, but we still have school. We're online. We have a Zoom. Yeah. This is going to be fun. So what Tuesday is going to look like? Has anybody seen the schedule for Tuesday?
Yes, it's only like 20-something minutes.
About 20-minute classes. When does first period start on Tuesday? 8 a.m., not 7:15. You do have to be on the Zoom. If you don't show up to your Zooms, you get counted absent for the day. What this class is going to look like. This class, you know how fifth period is normally the full length even when we have weird schedules? It's only 20 minutes. Because we start at 8 a.m. and we're done by 11 a.m. So we're done right around lunchtime. 20-minute classes, you have to show up in the Zoom. If I don't see your face, if we don't talk to each other, you get counted as absent. Don't just like pop in and pop out. That's not enough time for me to see you and record you as present. All right? Show up, say something to me, I'll record you as being present. If you have questions about the review, I will happily answer those questions. If you don't have any questions about the review, we're going to treat Tuesday just like an in-class work day on the review. So if you just want to work independently, after you sign into the Zoom and I've counted you as present, you may do that. You don't have to stay in the Zoom for the full time. Unless you discover you had a question, you hopped out, you're working on the review, you run into a problem, it's still fifth period, you can hop back in and ask me. You guys feel like you understand what Tuesday looks like? We also have Wednesday and Thursday face-to-face to review for the test. Friday's the test. Cool beans? Awesome.